All right, welcome back, everyone. Today we're going to be talking about intermediate OOP. Now, in reference to intermediate OOP, we're really going to be diving into the idea of, hey, what are classes and what are instances? What is their differences in between them, and where should properties live and methods live within the class level or the instance level? As of now, the only class or the only things that we all have created are instance properties and instance methods. But today we're going to start talking about creating class methods, and we're going to start talking about creating class level properties. And we'll start talking about why they're necessary here shortly. So in overview, we'll start diving into intermediate OOP, instance versus class attributes, instance versus class methods. Again, friendly reminder, everything that's being taught today, you will be assessed on coming this weekend when the assessment is delivered on Friday at 12 o'clock CST. All right, any questions over what we'll be covering today or how you'll be assessed? All right, let's dive into some class versus instance. So when you think about a hierarchy of OOP, think of an organization like classes that has many departments within it. Now, this department can be represented as instances. This is the way I like to think about it, right? Maybe here we would have something like a class, and let me put that here, where we can call this department. That would have some sort of init method that we know would take in self. All right. So here you should be able to see on the lower hand side of my screen that small class decoration that I've created. Oh, that is not what I meant to do. Wonder if I can bring it back. All right. When I'm referencing here to the overall business or organization, so this entire building that we're seeing here on the left-hand side, that would be in reference to the class declaration. So the class is the entire business that's holding every department. And every time I create a department, that would be something that gets actually initialized and gets passed through the init method. So an instance of this department is living within the class. At the very beginning of the program, I mentioned that everything inside of software engineering is essentially just boxes inside of boxes. When we take a look here at our code example that we'll be working in today, we're going to be working into creating a series of tasks. Now, when we go into creating this series of tasks, what we're going to be talking about is generating a couple of class-based properties and methods, and a couple of instance-based properties and methods. Here on the left-hand side, you can see that the task, which is the class itself, holds all of the instances of task that has been created. And if you want to see a different visualization of this, well, you can see there we have a task with task instances being formulated from said task. All right. Can I get somebody to read this slide here?
Class attributes and methods can be accessed by all instances of the class. Instance attributes and methods can only be accessed by said instance, and changing these attributes would only reflect on said instance.
All right, perfect. So class attributes is something that belong to the entire class, meaning the entire class can interact with it. And something within an instance is only that should be accessed by the instance itself. So, little example here in the drawing that we created regarding our classes. If I were to create these classes, every single one of them would have a task name and completed, right? Every single instance of the class of task has a task name and completed. If I were to call encode tab to print task.name or task.task name, what would that return?
Nothing good?
String.
Yeah, nothing good. That's one. Cody?
I just seen string, so I said it would return the string. I
Right.
didn't
So
know if that
that's
was just like a value placeholder.
for now, it's just a value placeholder, right? We know that this is going to be set to a string. Um, but what this
But
would
you're calling
actually
it on the
return
task, not the instance, right?
exactly, this would actually return a form of error, or it would just tell me that this is a property that belongs to the task, but wouldn't actually have a value assigned to it. And I wouldn't be able to interact with the actual value of task underscore name because that doesn't belong to the task class. It belongs to an instance of a class where the opposite could be said, where if I was to do something like new task is equal to task that takes in a name, such as, I don't know, write some code. And then in my next line of code here, I go and I say, well, now I want to print new task dot task name. The line of code that we just read on the left-hand side would return an error. Again, because the class has no access to the property task name. And the one on the right-hand side would work properly because new task is an instance of the task class and has access to the property of task underscore name. Right, so there we can see on the left-hand side, something that would return to us an error. And on the right-hand side, if I didn't have the syntax problem there, this would return a successful print statement where we would see write some code. And let me actually just, boom, there you go. All right, so that kind of clarifies things as far as at the task level, all right? Or when we were talking about how we could access an instance. But what about this list of all tasks? If I were to say print task dot list of tasks, would this statement be successful or would it return an error?
It would be successful because that's a class level attribute.
Nice. Yeah, so this would successfully print a list because list of task is a class level attribute. Awesome. So there you go. I have a little bit of information about how this would function up to this point. Now let me bring up a separate example here. And let me just scoot these over to the right-hand side a little bit more so that way you don't get it confused. Let's start talking about a new task, right? If again, we have our new task and this task takes in a title. You can say our title is teach. And now I go to say print new task dot list of tasks. Would that statement be successful? Well, the
Uh,
statement would actually return successful as well. It would actually print a list of tasks. And this is because all instances have access to parent properties, where the parent would be the class itself, and the property here, so i.e. list of. So there we can see a little bit of an example as to code that would be successful and an example as to code that would be unsuccessful. All right, here up above, we are taking a look at an example of a class level attribute. Oh, excuse me, class level property. And down below, we're taking a look at example of a instance level property. All right, let's open it up for questions. Let's hear it from Nick.
Would the task when you hold on, new task dot list of tasks, would it be updated with the full list, or would it only be updated to when that instance was made?
Would be
As in,
updated.
you had task A, task B, task C. Would task A have information about task C? And if you initialize them in that order, or no?
That's a great question. And the answer is yes, right? Because now this list of tasks is global, meaning that it exists within all instances with the same data. So if task 1 is now generated, so now we have task 1, we have task 2, and we also have task 3. All 3 tasks have been generated and they're saved in the list. Well, task 2 here can successfully run the code of print. Let's just call this tasks 2 dot list of tasks at index 0.
And that would return task 1, approximately.
Correct. And this statement would return task 1. Because list of tasks, eventually I'll get this right. There you go. Of tasks exists with the same data across all instances. All right. Does that answer your question? Perfect. Michael?
Next to task in parentheses, you have teach in quotations. Does that do anything at all or mean anything?
We're talking about here?
Yep, like the new task equals task, parentheses teach.
Yes. So here, what I am mimicking is my initializer because I have in my task instance something called task name that would take in a string. I am mimicking the behavior of passing in a string that would fill in that task name.
Okay, I see now.
Awesome. All right. Any other questions? Okay, fantastic. Let's continue on with our slide deck. Oh, actually, that was the slide deck. Perfect. Let's continue on with our code. So now we know a little bit about classes, the way they work with their properties, and we'll start talking about their methods during part 2. But for now, let's actually take this drawing and these small segments of code that we've written so far and actually create it into a class. So let's start off with our regular class declaration and our class statements. Oh, that is a lot of stuff. All right. We already know how to do class declarations and actually make our init methods. So before we start diving into anything about this global property or being able to create a class property, let's just go ahead and stick to building a task that will have an initializer that can take in a task name and a completed value. So let me go ahead and start this off with Alex.
So first you would have to make the class. So you would do, yeah, class, then whatever you want to name it. Yeah. And then define init. Yeah. And then the parentheses, self, and then the variables that you want to initialize it with.
Okay, so we have our task name. And then we have, which we know is going to be a string.
And then
And then we
completed.
have completed, which we know it's going to be a Boolean. And we know that this method is not going to return anything. All
Mhm.
right, what's next?
Then you would do self dot task underscore task underscore name, I guess. Because we're not planning on changing it, or is it we just doing self dot task? Yeah, task underscore name equals task underscore name. And then completed self dot completed equals completed.
All right, perfect. We'll move on into getters and setters here shortly, but I see a hand up. Go ahead, Daniel.
When you want to set the completed value as false, just as a default,
We
because I
absolutely can.
assume you wouldn't put in a task that you've already completed into a task list.
Yeah, let's add that in there. Awesome. So now we have a default value for false. All right. Chase, could you move me through the process of creating a getter and a setter for our task name?
Yeah, sure. So next we do property, which is going to create the getter. Then we're going to define uh, def task name, and then we'll put self as the parameter and colon, and then we'll say return self dot task name, and that'll return task name as the getter. And then next we'll do at task name dot setter, and we'll say define task name self comma task name, or no, let's do new task name or new name. Yeah, that works. Okay. And then we'd probably do some conditional, like if uh new task name is not, maybe, or I don't know what our conditional would be, but let's say is not self dot task name. Like if it's different, maybe.
Okay, so let's just do something like is alpha, right? And let me
Yeah.
make sure that this is a string. Oh, not now. This is going to return none. This is also going to return none. All right, perfect. So is alpha, which is a string, and
Okay.
let's also make sure that let's just, for simplicity's sake, let's leave it at that. Just making sure that all of them are characteristics. All
Yeah,
right,
makes
how would I
sense.
set it?
So to set it, you would then do uh you do self dot task name is equal to new name.
Okay. And if it doesn't meet this requirement,
If it doesn't meet that requirement, then you would raise an exception and explain it contains must contain only alphabetical characters or no numbers.
all right. That's pretty close. We almost got it. Um, we were able to create a task name, and here we have a return of self dot task name. But it
Plus an
seems
underscore.
like awesome. Yeah, that's a great catch. But let me go ahead and explain what this logic is doing here. So what we're doing here is we're actually doing a form of recursion. That's what's happening inside of this statement, right? We know that self.taskName refers to the getter if there's not an assignment. There's not an assignment here. So what we're saying is we're calling self.taskName, and in return, we're going to call self.taskName. So then this line just takes us back up here. And then again, and again. Right? It's an infinite loop of recursion. So what Nick just mentioned was adding a underscore. If I add an underscore, well, then self.taskName doesn't exist. So where else do we need to fix our code, Chase?
Uh, well, we need to change that in the init function as well, correct?
Not in the init function.
Okay. Let's see. In the setter as well.
Perfect. So we would
Yeah.
set it in the setter. And there you go. And then finally, we could do an else here. This is my mistake. I forgot the logic flow there would still trigger because there's no return statement. All right. Now let's open it up for questions. Andy?
Um, could you just like give me a brief explanation? You said like infinite loop. That's that kind of really helped me out, I think, because I was trying to figure out that underscore thing. And then the second question was why if there is a return, why is there none for the property?
That's a great question. This is wrong. This should not say none. This should return string. Thank you so much. Good catch on that one. All right. Now, when it comes to this task name, if it doesn't have the underscore, we're just calling the function all over again. And same thing down here. If we didn't have that underscore, what we're saying is we pass in task name, right? Task name gets passed into the initializer, and then it gets set to self.taskName. Well, self.taskName identifies, hey, there's an assignment here. So what I'm looking for, or what I'm going to check, is to see if there's a setter for a naming convention of task name. So it finds task name as a property. That's great, but we have an equal sign, so this is not what I'm going to use. And it comes down here. When it comes down here, it passes task name as the new name. If the new name proves to be true here, we would call self.taskName with an assignment. Well, now, this block of code in line 14 is the exact same block of code in line 4. And what this is doing here is just saying, oh, well, we're assigning, we need to find the setter all over again. So if we need to find the setter all over again, then we'll just send it back here. And then it passed the task name. Task name meets our criteria, finds the setter because we have the assignment, and then it just passes it back over and over and over again, right? So that's why it's called an infinite recursion or an infinite loop. So what we're doing here is instead, we're adding this underscore. And by adding this underscore, when the initializer gets ran for the very first time, it goes through. Same process, pass the task name down, the task name gets assigned. Here on line 4, that tells it, hey, I got to look at the program, see if there is a property. Okay, there is a property named task name. So there should be a setter. So it looks through. Okay, I'm not going to use this because this is a getter. I know I have assignment, so I need to go to a setter. And then it moves on to the setter. Passes the new name as the task name. It meets our criteria. And then this line of code here in line 14, in the first time that this is created, it causes our code to actually generate self dot underscore task name be equal to the new name that was passed down there. Right? So that's why that works, or that's the breakdown and the flow of how that is created. Is that just your question, Andy?
Yeah, that helps a lot. That was like, I think that was a big aha moment for me for this property, getter and setter. Thank you.
Of course. All right, Nick.
Is there a name for those things in line 4 and 5 versus line 6? These, I guess, I don't know. In my mind, I'm calling it a ghost variable. It's something that's created but not explicitly called directly inside the init function.
I see. There's
Or
still
ghost attribute. I don't know.
I don't think there's an actual acronym for it. They're still just defined as property values within the class. I get why we would think that they maybe have some sort of like different terminology to reference them, since technically they don't exist or they're not being created here, right? They're being created down below. But far as I know, there's not a separate terminology for them. I'll see if I can find something, and if I do, I'll make sure to pass it in the chat. All right, perfect. So now we have our getter and setter here. We were able to create a getter and setter for our task name. Now let's go ahead and create a getter and setter for something if it is completed. And let's go ahead and pass that on to Aaron.
All right, so a getter and setter for task completed. So we'll start with the at property to start the getter, and then define completed, and then reference self colon, and then that's going to return self dot. Let's do underscore completed.
All right.
And then for the setter, it's going to be at completed dot setter. And then you're going to def setter, and then, or def completed, and then you're going to pass in, you're going to reference self, and then completed underscore status, or new completed, yeah, status, and that'll be a Boolean. And then that should, okay, yeah. And then let's do a gate there. So if status is Boolean, or wait, when you specify Boolean in line 13, does that automatically create that gate that we're looking for in an if statement?
It does not,
It
right?
does not.
So although we are essentially mimicking a typing or a typecasting there, it's not going to throw an error if somebody utilizes this function incorrectly. So we still have to handle it within the if statement inside.
Gotcha. Then some sort of if status is a Boolean, so is the type or is instance Yeah, that. Then self dot underscore completed will equal status. And then enter, you'll raise an exception if that is not the case, and say status must be true or false.
All right, perfect. So now we were able to create our entire task there. Now, before I open it up for questions, or actually, let me open it for questions. Go ahead, Dan.
So I've noticed that a lot of the test cases, when we go to like, because initially I was like raising either, an exception or a value error. The test cases were not accepting the exceptions or raised errors. They were expecting a return string with what, the error was in the string. Um, will that be provided to us in the documentation of any of our future assessments? Like, we want you to raise an exception, or we just want you to return a string with what the error is?
Yes, that will be specified within your assignments and or assessment.
Thank you.
Of course. Carlos?
So on line 10, should that getter return a string or a boolean?
Oh, thank you. Good catch. Boolean.
What would happen if you do keep it as string? Would you get an error?
No, it would treat it perfectly fine. So this
Okay.
typecasting is just for us as developers. So later on, if I go to call any one of these properties or methods, it's going to actually give me, as a developer,
Okay.
a message saying, hey, this is what it takes in, and this is the type that it should be. But if I pass in the wrong type, the code's still going to be executed. It's just going to raise an error.
Okay.
Return
So it's not
value
necessarily
annotations.
so is it trying to typecast, or is it just basically like a note for, like you said, for the developer?
Just a note.
Okay. Thank you.
Of course. Andy?
Just for if we create an instance and we try to change the property task name without the underscore in front, would that make the entire thing go through the setter? Or would there
Without
be
the
an error?
underscore? No, everything would go through the center.
It would go through the setter. Okay.
Yes. So let's go ahead and create our new task. Let's do new task, make that equal to our task. Currently, the task that I have is write some code. It is all alphabetic. And if I go into printing my new task dot completed, that should give me true or false. If I go into printing my new task dot task name, that should give me my name. If I try to, try to have new task dot name be equal to, or excuse me, task name be equal to a series of numbers, that should raise an exception. We'll take a look at that exception. And then if I try to change my Boolean variable to something like is completed, this will raise an exception as well. So let's take a look at this. And actually, let's do some successful information now. So now let's go ahead and do new task dot task name be equal to teach a lesson. And let's do new task dot completed be equal to true. All right. So we're going to create a task. We're going to see its default values that it was created with. We'll then attempt to change them to something that we know will trigger our exceptions. And then we'll change them with something that we'll know that will be successful. All right, so it looks like we got a couple of things here. So let's take a look. All right, so here's my first error that is happening on line 31. So it looks like when I went to go create an instance of this, it returned an error. All right, so a new task. What's happening is we're passing it to the task. And the exception that is being raised is task name must contain all alphabetical characters. So let me see.
I think you put spaces in there. Does it register spaces?
That will do it. Oof.
So our code worked. It did exactly what we told it to do.
That is true. For simplicity's sake, I'm going to go ahead and just change it this way to make sure that this will work. Okay. Yep. And then teach a lesson fails because there's spaces. Boom. All right. So there you go. Now we get our first couple of print statements. Here we see line 32. It comes out false because it has not completed. That's the default value. The task name is to code. We then try to set it to a series of numbers. It tells me, hey, this must only be alphabetical characters. So they raised an exception. We were able to capture the exception and print it. We then try to change the value of completed. It raised an exception and it tells us, hey, it has to be either true or false. And then we went through, changed it to something that we knew would actually work. Changed the completed value to true. And we get those final print statements of true and teach. All right, Carlos.
Sorry, could you go back up to the very first line?
Back up to the very first line. Are we
So-
talking about very first? Or
Yeah,
are
like the
we-
very first. Well, I guess line 3. Okay, all right. So I guess I just missed that part where you set the default value for completed as false. I thought we had just left it blank. That's what was throwing me off. I wasn't sure if it was returning completed when you were printing completed, if it was returning false just because it wasn't assigned to anything.
Got it.
Yeah. So that works. Thank you.
Okay, awesome. Any other questions? All right. Well, now I've created all this information. I have access to my different attributes and everything is working as predicted. I know it's working now. Well, now let's go ahead and throw a little twist in here. Let's say that I want to be able to have a list of tasks. Well, now what I'm going to do is simply outside of the init method and right before this class, I'm going to establish a new property. Now, this property is going to belong to the class itself. So I'm just simply going to write it as such. List of tasks is equal to a list. Nothing necessarily special when it comes to syntax, but you'll notice that what's the key word that is missing is now self. There's no self dot list of tasks. List of tasks does not belong to an instance, so it never ran through an initializer. It belongs to the class, and as long as the class exists, so does list of tasks. Well, let's take a look at what that means. I'm not going to create an actual task there, but I am going to call print task dot list of tasks. And in doing so, my code runs successfully, and I'm able to get this empty parentheses. Now, let's say I call one of these property values, such as task name. Or if I call task dot task name, and I execute it, you'll see that instead of giving me the actual value, it just tells me, hey, this is a property that exists for the class instance. So it's telling me this is a property object. That's all. Right? Nothing necessarily too crazy up to this point here. I can see the difference where I don't have access to instance property values. I only have access from the class level to class level property values. All right. Well, now let's see if we can say the opposite. Right? So here's my new task. If my new task exists and it is an instance, well, we know that it has access to the task name. We can see that it returns code. But now, does it have access to list of tasks? Will this be successful? Yeah, I see a couple of head nods, right? Dominic, why do you think it would be successful?
To be successful because the list of tasks is property of the class task and it has access to all of that.
Right. It is always going to have access to the class above. All right. So let's say we wanted to add this information. Well, what I can do is I can say task dot list of task dot append new task. And now if I go to print my new task dot list of tasks, let's take a look at what happens here. And let me actually create a other task here. Let's call this one teach. And let's do it this way. We're going to see the same attribute being printed from all three different tasks. We'll then change its value. And then we're going to see this attribute from two separate tasks and the class level. See what we have there. So if I come over to my editor, we can see that from task, from new task, and from other task, they're coming in as empty lists. Line 38 happens where we append a task into list of tasks. We did it from the class level, and everything remained the same. We have the same exact representation of this object happening across task, which is the class itself, new task, which is an instance of the class task, and then other task, which is a separate instance of the class task. Right? The instance of new task has its own property values, such as name and completed. But they also have access to list of tasks. Which is common between both of them. So this one's going to be global in scope, meaning that it exists across the entire class. And this one is local, meaning that it exists only within the concept of the instance. All right, well, let's see what happens if I change it from different levels. right? Because that does raise a question. Well, what happens if I do it from different levels? Well, the same behavior happened when I did it from a class instance than if I called this method from the class itself. All right, let me go ahead and open it up for questions. Nick? You're muted.
Would it be proper to say that new task and other task inherit list of tasks from the class task?
Inheritance is different. I don't think that would be a proper statement. That is a good way to think about it, but I wouldn't use those words as far as terminology.
Okay. And then in order to keep track of this, would you want some sort of code inside the task itself to automatically append these things instead of doing it out here after the fact? That way it's
We
done automatically?
Yes, and we'll
Okay.
be diving into that during part 2.
Okay.
Awesome. All right. Any other questions? Let's hear it, Justin.
I guess when you append a task to the list, and maybe this was addressed, are you appending the task itself or a reference to the task in memory?
The instance of the task, and the instance of a task lives inside in memory. The reason why it's being represented like this is because we don't have a repper or a string method. So by default, that's what it returns.
So it is appending the entire instance of the task.
Yes.
Okay, thank you.
All right, let me go ahead and add a quick representation method here.
Do those need underscores?
Task and completed do not need underscores because they're going to call the getter property.
That's right.
All right. Awesome, everyone. So up to this point, we were able to create a class. This class of task has multiple instance level attributes and one instance level properties and one class level property. We covered getters and setters, which none of that behavior has changed as of now. And a question to keep in mind to move on to the next one is, well, hard coding this appending process to actually add a task into that list seems like it's not very efficient. And there's got to be a better way to manage this sort of behavior. Now, keyword there is behavior, and we're going to be covering that portion during part 2 of our lecture. At this point, does anyone have any questions over how to create class level properties versus instance level properties? Let's hear it, Kevin.
Hey, sorry about that. I was actually like a lot of stuff was going on my side, so I wasn't really fully zoned in. But I think so with class level attributes, I remember one point like are they mainly used for like read only properties? Like you never really like I don't know. I remember being told, and you can correct me if I'm wrong, obviously, but I remember being told like class level attributes it's very rare, or you shouldn't really make them as much. It should just stick to like defining like the init and other methods. Can you explain a little bit more about that, Francisco?
Yeah, absolutely. So when it comes to class level properties, and I apologize, your mic came in a little bit staticky. So if I don't address your question all the way, please let me know. So the difference between, or the purpose between class level properties is that it's something that needs to be managed or something that needs to be accessible for all instances. In this case, what we need accessible for all instances will be a list of tasks, and we'll cover later on a behavior as to why we would need this. Now, is it common to actually have something that you need across all instances? It's very much situation dependent, and it's not as common as you would think. right? Class level properties are rare in the fact of where they're actually used in the real software engine in real programs, right? They can be implemented, but they're not very common. Now, for the second portion of your question, which was, are they usually read only? They are read only in the sense of the way they are accessed should only be to grab information. But in order to change their values, that's what we have class level methods for. So we'll create methods that live at the class level that will interact with these properties that live at the class level as well. Does that answer your question, Kevin?
Yeah, you answered it. Thank you.
Awesome. All right. If there aren't any other questions, I'm going to go ahead and stop our recording here. Let me go ahead and share this image with us in the questions chat so that we have that with us as well. And I'll push up our code up to this point to GitHub as well so that we have it available for assignments. Let me pause recording. Perfect. Welcome back, everyone. Let's go ahead and continue with part 2 of our class today. Today, in this portion of our class, we're going to go ahead and dive into methods. There's instance and class level properties. There's also instance and class level methods. We're going to talk about why and how to apply them. Now, before we dive into that, we got a little bit of practical application during our break here. Does anyone have any questions over the material that we covered up to this point before I move into methods? Go ahead, Carlos.
I don't know if this is what you're asking, but so what I'm having a little bit of issues with now in that exercise was the basically how to auto increment the ID whenever you create a new instance instead of like manually putting in an ID like based and you have to check what the previous one is. I don't know if that makes sense. And I don't know if that's what you're asking right now.
I was asking more in regards to the concepts. In regards to the exercise, we could cover that after the class.
Okay, yes, sir.
Awesome.
We're good.
All right, perfect. Let me go ahead and comment all of this nice block of code here out, and let's dive into our methods. Now, methods, as we know, are a representation of behaviors or actions. Currently, I have getters and setters, and I have 2 properties, which is task name and completed. Now, I want to create a method for this task where we complete the task. So I'm just going to quickly write one here. You say def complete task. This is a class level method, so it's going to take in self. And all it's going to do is it's going to print self.name. And I apologize, I forgot my F string there. And this is task name is being completed. Let's go ahead and make this a little bit fancy and import time so that we can do some sort of little time wait there. Let's say time.wait, or excuse me, sleep, where we'll sleep for 2 seconds. We'll print the same statement and say it's almost done. And then we'll sleep 2 more seconds. Finally, change our value for completed. Make that equal to true. And then print self or F string here of self.task name is now completed. All right. So a couple of things to point out here. Complete a task is interacting with 2 separate properties. What are those properties? And let me hear that one from Daniel.
Can you repeat the question real quick? So you said, what is the properties of self.task?
I'm asking what properties is the method complete task interacting with?
So completed task is going to be interacting with the getter for task name, and also is going to be messing with the setter for completed.
Awesome. So it's interacting with two separate properties, one task name and the other the completed. Now, both of those properties, are they class level class level properties, or are they instance level properties? And I'm gonna go ahead and send that one to Andy. Are you thinking, Andy? Can you hear me?
Sorry, I must have missed something.
Oh, got it. Let me go ahead and review here. So I'm asking the property of task name and the property of completed, does that belong to the class or the instance?
That belongs to the instance.
Perfect. So we know that a method or a class level method will interact with, or excuse me, this is instance. An instance level method will interact with properties of the instance itself. That up here to drop that comment. All right, now let's call this method here. I have my new task. I'm going to say complete task. It doesn't take in any arguments. And then I'm going to print new task dot complete just to make sure it worked properly. I'm going to send that in my terminal by running my main script. You can see the code is being completed. Code is being completed. It's almost done. And then code is now completed. And finally, when we go to print our task, new task completed property, we can see that it returns a true Boolean statement. So we were able to create a method that interacts with instance level properties and conducts an action. Up to this point, everything should seem pretty familiar. We now have our instance, which is unique to each class, right? If I were to print, or excuse me, which is unique to each class instance. If I were to print the completed value of other task, that would still return false. And that's because the values of the instance are local, right? They are not updated in a global scale. Well, now let's talk about some class level methods. What would be a class level method that would interact with list of tasks?
Append method. Add.
Yeah, something that would add to the task. Okay, would we maybe want to create a task itself and then add it to the task? Well, I just utilized the and word, right? So I know those are two separate purposes, so they should be two separate functions, or excuse me, two separate methods. Well, let's start talking about a class method. Now, just like we have a decorator that created a property, when I'm creating something that's going to be accessible at the class level, I am also going to utilize a decorator. And this decorator is called the class method decorator. I'm not going to make it all the way at the bottom because I want us to kind of be able to see this list of all tasks here. So I'm going to make it right up here. I'm going to say, hey, at class method, that's a statement saying that the following method that I am about to define is going to belong to the class. So the first one will be of creating a task. So create a task. Now, before we were passing in self because this was referencing to an instance, all right? So we know self is a representation of an instance itself. Well, now in class-based methods or in class methods, we're going to go ahead and pass in CLS. Again, CLS and self are not keywords. That's just going to be the standard inside of Python for representation, right? And what we're representing here, CLS, is representing or is a representation of the class declaration. All right, so create a task can take in the following. Let's say we have our new task here. And what our new task does is it creates a dictionary that has task name, pass in the input function and say, please input your task name. We have a completed, which we know we're going to need to typecast to a Boolean, or we could just simply, by default, always make it false. Now this task name, we know that it has to follow some sort of complexity here, saying that it's alphanumeric. So let's create a helper function to actually validate that. Let's say, hey, in here, I'm going to have a helper function that is going to validate name input. It's not going to take any parameters. And all it's going to do is return a string. Now here, I'm going to ask for that information. I'm going to say task name is equal. And I'm just going to go ahead and strip this line of code here. And I'm going to say if task name dot is alpha, then I want to return task name. Otherwise, I'm going to return the validate name value all over again. That way, if the user places something that is incorrect value, maybe I add a print statement there saying print, please enter and is alpha value. And then I call the function. Well, to call the function, I'll call it in line 17, saying validate name. And I guess instead of validate name, let's just call this name generate name. All right. So now we have a way to generate a name, capture that information, and we have a new task that has been created. Well, now let's create the task. Let's say the task gets created here. So what I'm going to return is a value of the class itself, where task name is equal to new task dot get task name. And completed is equal to new task dot get completed. All right, I just wrote quite a bit of code. All this method is doing is it is generating or creating an instance of the class, of the task class. The method we created here is simply captures user input to generate a name for the new task. And down in line 25 is where a new task is instance is created and returned. So here we know that this function or this method is going to return a task. Interesting. It won't let me call the task itself. So let's catch that out. All right. Does anyone have any questions about this block of code? Let's hear it, Andy.
For the generate name, the way I'm looking, like, correct me if I'm wrong, there is no fail safe, right? It's just gonna keep repeating itself if not correct format input is not inputted.
Yes, unless I provided correct value, it's just going to keep repeating itself.
Okay. All right, makes sense.
Awesome. All right, well, let's call this and make sure that it works properly. All right, I'm going to go ahead and say generated task is equal to task dot create a task. And then afterwards, I'm going to print the generated task. All right, so it goes down the code block. It was able to generate those two tasks there. And then afterwards, I'm going to generate a task. Well, when I generate a task, that tells me, hey, please input your task name. Well, my task name will be to clean. All right, and then in the print statement, we get, hey, there is a new task. This is my representation method that I've created here on line 70. There is a new task that was created. The name of said task is clean, and I need a space there. And its completed value is false. All right, any questions about this code up to this point?
So that just takes, instead of us having to do like line 74 and 75, it shoves the generation of the task as a method inside of task class.
Yes. That's
Okay.
what we created. Carlos?
I think I might have missed something. When you do the dot get and then the like task name or whatever it was up a little bit higher. Yeah, so task name equals new task dot get. So I'm not understanding that part. I feel like that might be pretty easy, but
Got it. So what this is essentially translating to, it is translating to task, where task name, which is the attribute that we pass in the initializer here, right? We need task name, and we need completed. So we're telling it where task name is assigned to my new task, which in this case, it's the dictionary on line 23.
okay, so is the dot get the same thing as doing new tasks bracket and then in quotes task name?
Yes.
Okay, okay. All right, that's what was gotcha.
That's what was missing.
So
Okay.
that's what was missing there. So which one is a preferred method then for dictionaries? Or I guess the syntax to do the dot get or to do the brackets.
Utilize the dot get. If you utilize a bracket notation and that property, or excuse me, that key doesn't exist within the dictionary, it's going to throw an error. If you utilize the dot get method, instead of throwing an error, it's going to return the value of none, letting you know that the key doesn't exist. So
Okay.
it's just to make sure that your code doesn't break, utilize the actual methods that are created to be able to access information inside of dictionaries.
Gotcha. Yes, sir. Thank you.
Of course. All right. Andy?
Yeah, there's like inception in my brain right now. Trying to figure out where does it start and where and like the sequential order of the process of going through. Is the getter and setter still included with this new class task?
Yes,
The-
that behavior never changed. So let me go ahead and
Can we get
walk
a flow
us.
chart?
Maybe we could do another flow chart. Yeah. That worked out pretty well yesterday. Or at least I hope it did. Let's go ahead and go through this.
Would you be able to put these flow charts somewhere we can see them after class?
Yes, they're up on GitHub inside of demos and notes.
Sweet.
Let me see if I could share this. Yeah. So at the very bottom of this link that I'm sharing here on Avenger questions, you'll find the flowchart from yesterday. All right. So let me go through this portion. All right, so here I'm going to do the task dot generate. I think that's what we call the create task. Change that back into our funky stuff. All right, so there's our first portion. The next one that we'll be diving into will be the task dot init method. After that, we'll go through the process of, and I wonder. Nice. All right, so this is from yesterday. Okay. Let me do a couple of fillers there just to make sure we are good to go. And let's start breaking these down. All right, so we run the task.create task. And we know that task.create task, essentially, as we break into the code here, what it's going to do is it's going to create an dictionary with two values. We have a dictionary with the value of task name, with the key value pair of task name, and we have a key value pair for completed. All right, so that's what task.create task does. From there, each one of those attributes or each one of those key value pairs, we pass each key. So one for task name and the other for completed. So we go into this create a task. We start working on creating this new task here on line 23. We grab the user input to grab a key value pair of the task name and completed. And then afterwards here on line 28, where we're calling CLS and passing in this parentheses. Again, this is the equivalent as calling the task itself, because we know CLS is a representation of the task declaration. So therefore, it goes into our init methods, and then it follows the same flowchart from yesterday, right? It looks through the class and attempts to find a matching naming convention for a task name. It's able to find one that we created for a getter and setter. It sees that there's an assignment, so it goes to the setter. And then finally, the setter is created, where instead of self.wait, we have not make it transparent. We have self dot task name. And self dot, what was the other one? Completed. There you go. All right, and there's the flowchart. So now we have a new instance. Finally, after all of this is created, our task create goes through the process of outputting or returning. How can I symbolize a return? So the entirety of this code then produces a new task. Instance. All right. Go ahead, Andy.
So I understand the class task was referencing the things that were in the instances. Or not the instances, the init. And I was wondering if the init has properties that the class task does not reference. Does that mean those other properties have to be individually accessed?
I think I lost myself in your question. Could you ask that one more
Got you.
time?
Yeah. So for example, if we go to the problem that we were having, the exercise, it was talking about make, model, year, blah blah blah, right? So if I was only to focus on make and model, not and exclude the year in the class task that you were going through for the user input, let's just like an error, user error, right? That we didn't, not user error, the coder didn't include the year into that. The year wouldn't be included in the actual like the class task. I'm trying to freaking word
The
my
init method, the constructor.
Yeah, so the constructor would not be initialized, right? So that the year would be left out, right?
The year would not get passed into the initializer because it wouldn't have a matching argument. Right.
Got
So
it.
then when
So
you create a new, every time you create a new instance of the class, it would be missing that property.
okay, makes sense. So when you created this class task, for the user to enable the user input. That essentially cancels out the whole other method that we were using to create an instance, right?
It doesn't cancel out the method, the init method. If what you mean by cancel out
Not
is we
cancel
wouldn't
out, but
use.
it makes it's more user friendly to use the generate task or
Yeah, it's streamlining the process, right? It's giving us access to have some more control, capture some user information, kind of like
yes.
encapsulation and abstraction, right? We're hiding the complexity of it by just simply adding a method so that we can capture user input rather than hard coding it like we do in line 77 and line 78.
Yeah. Okay. So that makes all sense. Yeah, and
Awesome.
if when especially when you mentioned the pillars. Okay, thank you.
Awesome. All right. Any other questions? Okay, great. So now we were able to generate a task. But just like we mentioned earlier, that's not the only thing that we want to achieve, right? We want to generate a task, but we also want to be able to add this task into the list. So let's go ahead and create a different class method that would do that. So how do I create a class method? Let me go ahead and pass this one off to Carlos.
So we do the at class method
Right.
and then define and then add to list of tasks.
Add to list of tasks. Awesome.
And then we would pass class CLS and we have to pass. Do we have to pass the instance of that class that we just made?
Yeah. So let's say instance of task.
Okay.
All right.
All right. So then we would just do CLS dot list of tasks dot append, then instance of task.
Now let's just do some sort of print statement to let us know this was successful. All right, let's just go ahead and say, let's throw an F string and say list, or excuse me, instance of task has been added to the task list. And then end it by printing out the task list itself. Do it this way. All right. Perfect. Well, now, where would I call this actual method? And let me pass that question off to, let me hear that from Keegan.
So you could probably pass that at the bottom below where you have instantiated an object from the class.
Okay, great. So I could probably pass it down here, right? I can say, hey, task dot add to list of task, and then pass in the generated task.
Mhm.
All right. Let's see what happens when I run this. So I run Python main py. I am going to clean. That's going to be my task name. And then we get, hey, clean is now happening. So clean has been added to the list, and the only item on the list is to clean. Perfect. All right, so I have created a new class method. All right, I apologize, sir. I'm going to go ahead and pause our recording here for a split second. All right, welcome back, everyone. Let's go ahead and continue. We left off where we had completed two separate methods here. One, which was able to create a task, and another, which was able to add this newly generated task into the list. Well, let's start going through a little bit of code cleanup because there's a couple of places where we are not being as efficient as possible. So one, if I'm creating a task, do I really want this add to list portion to be a separate step? Probably not. It's probably that I want to have something that I want to happen automatically. Well, if that's the case, I'm going to come up to my init method. And within my init method, I'm simply going to add self.add list to task and pass in self. Right, this accesses the task level method of add a list to the task. And then we pass in self, which is the instance that we have created. And let's take a look at what happens when I run my code. You can see that I have two that are not using this create a task method. So we should see a little bit of a different output here shortly. So let's go ahead and run this. All right, so now we're getting some output. So we get code completed false has been added to the task list. Then we get code completed false in list. Finally, we get teach completed false has been added to the task list. And then it starts listing the items. Now we have two separate items. We get code completed false in list and teach completed false in list. When I go and create a new one, such as clean, we get clean completed false has been added to the task list. And then all three of my tasks now exist within the list. All right. All right, let's hear it, Andy.
It just came up to me like when you were talking about, well, when the string puts out added to the list, I'm wondering, are these things being edited or are they just being added to the list? So it's same thing over and over again that's being added. Do you
The
understand what
only
I'm
thing
saying?
that's
Because initially you put clean,
uh-huh.
And then you called clean afterwards and afterwards. So it's just like clean over and over added.
No, so clean only gets added once. So this statement here is where it gets
Yep.
added. Let me come up to the method here. Right, so that's where it gets added. And then afterwards, I iterate through the list and I print each individual item within the list. And that's why we keep seeing it being repeated.
Okay, makes
All
sense.
right. Maybe it will be easier if I just print the list itself. That way we can actually watch it grow. All right, so here we get, hey, this has been added to the list. The list only has one index. We get teach has been added to the list. The list now has two indexes. And then we can go and input our name here, which is clean. Now clean has been added to the list, and our list now has three indexes. Does that answer your question, Andy?
Oh, yeah, if you put in, let's say, it makes sense to me. It's just Okay. I'll just have to go through it myself. Yeah. It's just new thing. I'm trying to wrap up my head around it.
Okay, awesome. Cody?
I might have missed something, but I'm not understanding why you're adding the class method to the instance properties. Because can't you, isn't it already accessible to the instance? So why do you attach it to the instance? So the add to list is already accessible off of an instance, so why add it to it? Like at the
So
very
this,
bottom, if you defined a new task, like you did new task, you could do new task dot create a task already without even assigning it to the um, property. If that makes sense. Am I wording that right?
I don't think I'm tracking your question. You got to help me out here. So
Yep, sorry. In your
what, go ahead.
instance, you're attaching the class method inside of the init.
Hmm.
And I'm asking, like, what is the purpose of that? Because you could already grab that class method without it being inside of the instant property.
Got it. So when it comes to the purpose behind that, all we're doing is saving ourselves a step, right? We created the method. We know that its end state is to be able to have a living record of all of the instances that have been created of this class task. So I could either use it myself, like I did down here on line 87, right? In line 87, I called it manually. But if I were creating classes just like I did with new task and other task, I would have to rewrite over and over again
Oh,
every single time a class is
I I think I got it now. That's automatically going to call those methods, right?
exactly, and then
As soon
send
as
it
you run the
straight in.
file, it's going to execute those and it's going to start asking for your inputs, right?
Yes,
Okay. Yeah, now I got it.
awesome. All right, perfect. So now we have our two methods. All of them are working correctly, but there is one more portion where I could clean up a little bit of code. That's going to be happening here. So I have a dictionary with key value pairs, where the key value pairs or the key names match the parameters that my init method is expecting. So instead of writing everything like this, what else can I do to pass those key value pairs where all of the values would be assigned the correct variable so that they match the init method?
Would it be task name, task, well, yeah, task name, comma, completed, um, equals new task?
Let's take a look here. Let me open up a Python interpreter down below. And then here I'm going to create a new task. And this task is going to take in a task name, where that task name will be code. And I'm going to create a completed argument, where it will be false, just like we have in our dictionary up above. Right, so need task worked correctly. Now let's say I want to take these key value pairs out, and I want to see what they create. Well, I don't know if we remember, but in Python and JavaScript, there's a concept called deconstruction. All right, so I'm going to either deconstruct this dictionary here so that I can get some key value pairs. So I'm going to print, and I'm going to pass in star star new task. And I believe this is going to return error because it's not something that's iterable. So that's what it tells me. It says, hey, this keyword argument is unexpected, task name. So it's saying, what do you want me to do with task name? Because I'm not telling it where it's going. And notice that it's saying it's a keyword argument. Print is a function. So let's try that line of code again. And let's try to nest it into something. Let's say new task. So now it tells me invalid syntax, got unexpected keyword, task name. Well, there's something going on. Why is it telling me that print, the function of print, is getting an unexpected keyword, task name? Well, when we go and utilize that spread operator, what it's going to do, it's going to grab the key and pass it to a function or a method and say, hey, if you are looking for something called task name, utilize the following value. So essentially the behavior that we're creating here is we're matching this task name. We're matching the equals to be the value, matching completed to be the parameter that we're looking for, which is creator completed. If we take a look at the error that we had earlier, it said an unexpected argument, right? And then we pass in false as the value. Well, let's take a look at what's going on here. I am now going to, instead of initializing this class the way I have up to this point, I'm going to pass in star star new task. And in doing so, we're going to see that everything works exactly the same. Everything has worked just like we did before. If I pass in clean, it will accept it and create my new instance of a class. So the CLS of new task, and here's the initializer down below as well, so we can view it. It's saying, hey, I have a key task name. There should be a parameter named task name. All right, well, this is what I'm going to be assigning to said task name. Then it says, hey, there should be a parameter named completed. Well, here's completed. Here's the value that I'm going to be passing into completed. And that is happening because of line 34, where I'm breaking apart that dictionary and passing in those key value pairs. All right, go ahead, Nick.
So it's actually looking at the parameter placeholder name and matching them up.
Yes, correct.
What happens if you put them out of order? Would it still be able to do it?
Yes, it will still be able to do it. So if I were to put them out of order, it's not looking at a sequence, right?
Anymore. It's actually looking for the specific text.
For the naming pattern, correct.
What is this called? Does this have a?
This is
I know
called
you
object.
use spread operator down there
Mhm.
to make that happen. Does this technique have a name or anything like that? Or just something we should know because it's very clean and nice?
It's more something that we should know because it is very clean and nice. I need to look it up to see if it has any sort of specific methodology or acronym that's attached to it. All right. So there you can see that now we were able to switch them backwards and it still worked because it's looking for that naming pattern and assigning the correct values. All right. So now we cleaned up our code quite a bit. Everything's looking pretty good. And we've been able to talk about class methods, instance methods, instance properties, and class level properties. At this point, does anyone have any questions over anything that we've covered so far?
Is this similar to how some built-in functions can take flags that aren't necessarily in order and still output properly? Like if
Right.
you say,
So
go ahead.
if we were to, let's take an example here. Essentially what this is doing, or the reason why it's able to pass in that output in a different order, is because it's still doing a hard assignment under the hood, right? If I were to try to create a new task and I pass in information out of order as such, like this, it would still succeed. Let me go ahead and print. That would still succeed. And let me just change this portion here. We can see that hello and true is being created. Now, the reason why this is still succeeding is because it's matching the parameter name and setting the value. And that's all the same. That's exactly the same thing that this star star method is doing. Does that answer your question? Okay, perfect. All right, any other questions? Okay. So now the last one to be done, or the last thing to be created, is a static method. Well, we covered class methods, we covered instance methods. What could a static method be? A static method is a method that is relatable to the class and its purpose and or function, but does not interact with any class and or instance properties or other methods independent from the class.
So is it like the function equivalent of a private attribute?
No, function equivalent of private attribute. I wouldn't call it that because a private attribute still belongs to the class, right? It's just something that you can't touch. Maybe, yeah, no, because not even a private method would function that way. No. This is more of, think about this as if you were to write a regular function. It doesn't need to live within the task. But the only reason why I'm placing it within the task is because it relates to the concept and or purpose of the task, right? So let me write this example here. So here I'm just going to go ahead and specify that this is a static method. Again, we have these decorators that are fantastic. And in this static method, I'm just going to say run the menu. So this is what the static method is going to do. I'm going to create a menu here. It's going to have a couple of options. So view tasks. And actually, the only option that I really have is create a task. And I guess we could just say view tasks as well. We could create that method really quick. All right. Now, my input or my user choice could take an input with the following string of menu. And then I can just make a sort of behavior here. So if user choice is equal to the string of 1, then I would want to return or trigger my task dot create a task. If I want to view tasks, so elif, and let me actually return run the menu. Do static methods take in an argument? I don't believe they do, but let me make sure. Yeah, they don't. Else if this doesn't work, or else if user choice is equal to 2, we'll go ahead and say task dot view tasks. I haven't created that one yet, so I expect that to return an error here shortly. And again, I'll return task run the menu. Finally, elif user choice is equal to 3, then I want to print goodbye and not return anything. Or I could just return none. And then else print this is an invalid choice. And again, return task dot run the menu. I'm just utilizing recursion to make sure that this menu continues running. So let me go ahead and add that number 3 there. And say exit. And let me quickly create this view tasks. So I'm going to scroll all the way to the top. I'm going to make a new class method for viewing tasks. I'm going to say at class method, define view tasks. That is going to take in CLS. And all it's going to do is say for task in CLS dot list of tasks, I want to print the task. All right. Don't need that print statement there. Perfect. So let me scroll down, make sure that my menu is running correctly. Everything looks like it's running great. So let's go ahead and run the menu. I'm going to call the task dot run the menu. Let's execute this block of code now. So as block of code is being executed, I can now create a task, or let's just go ahead and take a view at our tasks. Currently it returns nothing. All right. Well, now I want to create a task. So it's going to ask me, please input a task name. I want to code. All right. And it tells me code completed false. The task has now been created. All right. Let me view the task. We can see that there's only one. Let me create another one. Here I'm going to say clean. Create one more. That's going to be teach. And if I go to view all my tasks, all 3 of my tasks are viewable. I have code, clean, and teach. I've created all of those classes. And then finally, I can exit utilizing number 3 to get a goodbye. So this static method does not, at no point did it interact with any of my properties that belong to either my class or my instance. It access class level methods. That's completely fine, but it did not interact with the properties. Does anyone have any questions about static methods? And did that answer your question from earlier, Justin? Did that address it a little bit better?
Yes, just to clarify, you said, just to clarify, this just means that it is outside of the scope of both the class and the instance. It's just a bigger box, right?
Right. So it relates to it and it should be tied to it because of its behavior and the way it runs, but it doesn't have to live within it, right?
Yeah.
Because it doesn't touch any of the property values,
It
but
can't
because
hurt them, but it can use them.
exactly. All right. Nick,
So static method, if you were to start changing values inside of it, would it throw an error or is that just a convention?
it's just a convention.
Okay.
Justin?
Okay, just so I can make sure I understand this concept. So we create the getters and setters so that we can use them in the bigger box. So we make a little property level setter within the ins or a little instance level setter within it, so we can access it from both the global scope or the class level scope and the static scope, and the same with global. But you can't access it from a smaller box. Is that clear?
That's very clear. Yes. Static methods are still accessible from a smaller box, just like class methods. So let
Okay.
me let
So
me go
it's
ahead
just
and clarify that here.
creating these little grabbers from the smaller box so that we can reach into them from the bigger box
Right. Yes.
deliberately. Okay. This makes sense.
All right. So here we have our instance method. Outside of the instance, or excuse me, we have our instance properties and methods. Outside of the instance, we have our class level properties and methods. And then the best way to describe it is outside, we have static. But although outside, it is still chained to the class itself. It is not going anywhere. Regardless of where we move it, it continues to stay chained to the class itself.
And I guess the thing to take from this is like you can't really get anything out of the static box from the class or instance. You can use the static as like an interface to interact with the instance or class.
Yes, that would be a good way to look at it.
Okay, so for the example of the car management thing, for example, your terminal, your menu would be your static, and then everything, because since like, and then everything else would be handled by the class and instance.
Yes.
Okay.
Right. So as long as it doesn't interact with the properties that belong to the instance or the class directly, then it is a static method. And then as far as the data flow, so instance do have access, or it does have access. Ooh, let me make it this way. Boom. So an instance does have access to all of the class, and it also has access to all of the static. Right? So the relation of data goes from inboard to outboard. Just like a class can still access static. Let me make that orange there. All right. Awesome. I hope that's a good visual representation there. Any other questions?
I had one about what is the benefit of using this versus using another class as like your running function? So like this would be like the task builder. So like it has the functionality to create a task and view tasks, but like the menu, why not just build that as its own separate class and then just pass this one into it?
You
If
definitely
that makes
can.
sense.
You definitely can. At that point, what you're talking about is design-based decisions, right? It's how much do you want to make sure that things are coupled and things are decoupled. So the concept of coupling is where things are tied to one another. And then decoupled is where things are isolated into their own behaviors. Sometimes you want things to be as isolated as possible because if something changes in one place, you don't want it to affect the remaining of your program. But when we're talking about something like classes, if something changes within the class, it should reflect or affect everything with it that is related to said class. So that's why sometimes when it comes to that design-based decision, like keeping a list of all tasks, that's something that you want to make sure you maintain coupled, right? Does that answer your question?
Yeah. So, how do you decide when to use a static method? Because, like, I understand like using a list of tasks would be a good static method to have, like, where it prints out, view all of those. But like for the menu, for like the operational side, where it's just like leveraging that class itself, when would it be good to just put that as a static, or when would it be good to just put it into a separate class because it's just going to be leveraging the other one?
I would have to come up with an actual example. And if I try to come up with one on the fly, I'll probably end up generating an example that can become confusing or contradicting. So give me some time to sit on that, and then I'll come to us with an actual representation of it or a couple of examples that we can see so that I'm not misguiding the class in this presentation.
Thank you.
Of course. Andy?
I may have missed this. There's a static method. I'm assuming if since it's a method, it's part of the class. The diagram makes it seem like the static is outside of the class. Is that true?
So it still lives within the class, right?
Okay.
Its behavior never touches data within the class. The only reason why it still lives within the class, and let me move it, oh, can't really move it that way. The only reason why it still lives within the class is because we want to make sure that this behavior of that static method, its purpose or its entire existence still should exist within the class because it's where we want to isolate, we want to grab all of that behavior that belongs to the class and put it in one place, right? Well, this run the menu static method, it doesn't interact with the properties of a class and it doesn't interact with the properties of an instance. So therefore, it should still live within the static, it should still live within the class itself because we're utilizing functions of the class, right? We're still working within encapsulation and abstraction. We're still trying to give our user the best interface possible to interact with this class. So
Okay, so
instead,
kind of like outsourcing the method essentially.
yeah, kind of like connecting it and then, or hardcore connecting it, right?
Okay. Makes
Awesome.
sense.
All right. Any other questions? If there aren't any questions, then today we covered the difference between class properties and instance properties. We also covered the difference between class methods, instance methods, and static methods. That is going to conclude our lecture for today. Let me go ahead and stop our recording now.